All right, Rick, let's jump into the battery side of the business. Talk a little bit about the Cyclone. Again, just where it started and how it's evolved to where it is today.
Okay. We've been building a battery machine for 20 years, and the original battery machines we utilized some of the forklift industry batteries, and we're talking about like a 3,000 pound metal box full of batteries, and you throw that on a machine and it would last all day. But the downside of that was, if you don't have a forklift, you'll never be able to work on the machine, because the hydraulic pumps and things were underneath the battery, and so it made it very hard to sell that machine to anybody that didn't have complete access to the right tools to do any kind of maintenance. So as the battery industry kind of became more and more aware to us of what was out there, we started using some maybe some lead acid batteries, and then we decided, oh, that's not a good idea, because if they one of these batteries gets a hole in it, we're going to have an issue on the job site with some acid on the floor. So we got out of that and went to an Agm battery. We tried some gel batteries, but they didn't like the bouncing around and didn't like the being handled and things. So we went to the Agm. It's a very nearly indestructible battery. There's no maintenance. There's you literally cannot do any maintenance on them. So if you poke a hole in the side of one of those, they don't leak. If you turn them upside down, they don't leak. And whenever we ship those, there's not any special precautions we have to make sure that we do with those Agm batteries. As we started getting into the battery powered machines, we kind of stuck with old school technology that we kind of knew about. Again, the forklift industry kind of helped lead that with some of the DC motors, and we started out with 48 volt and maybe a couple of 24 volts. And at the end of the day, 20 years later, we are utilizing a 36 volt system. We've got enough battery pack in there that we can last all day. But we've transitioned from the DC motors into a variable speed motor that will allow us to have a throttle style, much like a propane. So if you're trying to creep through a doorway or go through an environment that has people in it, you can slowly go through that particular office area or environment so that you don't make any noise. You go slow and are very careful with the machine. And then once you get into the area where you're ready to take up some flooring, then you can crank the engine or the electric motor up to a higher RPM and start doing some production. But I think one of the biggest things that we've improved on in all of our battery equipment is the charging systems themselves. They're that industry many years ago, they were very reluctant to do what we called improvements. You have a 110 volt plug in, you plug it in, and if you tried to exceed what that thing was rated for, then it would pop the breaker and you come in the next day and you're not ready to go. So now in today's world, you've got a lot of different algorithms you can throw into those chargers. You can we've actually, the one we're using now is so advanced that we do like to have a short extension cord, but if we have a 50 footer on there, it'll still take care of it pretty well. But what's really nice is whenever the machine isn't performing like you think it should perform, or the charger's not performing like you think it should perform, then you can put an app on your phone, you can Bluetooth to the charger, and you can see what's going on. You can see if the guys are actually leaving the machine plugged in for a good 12 hours, or if they're just opportunity charging it for an hour. And so you can go in and diagnose why the machine may not be giving you a full day's runtime. With the Cyclone machine, we also send with it a 220 volt 100 amp charger that we would much rather see someone use that than the 110 volt charger, because we hit those batteries quite a bit harder and bring them up to full charge a lot faster and a lot harder, and those batteries tend to like that better. But as we all know, when you get into a job site, you don't always have 220 or 208 single phase. So we have the temporary power, which is probably 110 volts.
Talk a little bit about daily runtime. I know that it fluctuates between the type of application or type of removal that you're on. The industry will say that if you're doing a carpet job or VCT, a soft good job, you'll get better runtime than if you're doing something more along the lines of a tile or a hardwoods. Is that true? And if so, what really is that variation between runtime?
That is 100% true. If you're doing double stack carpet, you're going to really load that electric motor up. You're going to use more fuel. If it was a propane machine and you're working a propane machine harder, you're going to use more fuel. Maybe you're running a wider blade, you're going to use more fuel because you're asking to provide more horsepower. Same thing on the battery machine. You're using more fuel, you're using more amp hours out of the battery. And so you're going to deplete that battery faster, pushing it harder versus doing maybe, a re-scrape on some VCT adhesive. Not really much there to get up, but you still have to cover all that square footage to do that. If you're doing a re-scrape, just adhesive, we've seen up to 12 or 14 hours of runtime. But we've also seen where if you're doing some of the rubberized flooring that's glued down with some of the epoxy glue, it's really going to tax those batteries. So, you might get 8 hours of runtime instead of 12. I've even seen it down to 6 whenever they're really pushing it hard. And you have an operator that's not going to take any breaks, not going to go get a Coke or go to the restroom. He's just going to go out there and rock and roll on that thing. And which leads me to another point. If you want an all-day battery, how many square feet are you actually going to try to do? That Cyclone machine is going to travel at about 300 feet a minute or better. So 300 feet a minute, you're doing a couple thousand feet an hour at least. So add that up over 8 or 9 hours of runtime. That's an extremely large area. That if you've got that big of an area, you've done a lot of work.
If I'm an operator and I'm on a job, is there some sort of indicator? How do I know when I'm reaching the limit of that daily battery? Is there something that's going to tell me that I'm getting close and I need to recharge?
There's a battery indicator on all of our equipment. Of late, we've stretched the envelope a little bit on some of the gauges that we're using. It's in the past, the way that we would most of the industry would indicate how much battery you have left. They went off of voltage left in the batteries, and that's not a very good indicator, because if you're cranking a battery on a car, while you're cranking it, the battery voltage goes really low, but only during the cranking time. And then when you get done cranking, then your voltage goes back up. So it's the same thing whenever you're driving this Cyclone machine forwards, just transporting it, you may see a reduction in maybe a couple of volts. But if you put that like a 24 inch blade on that and start pushing some really hard debris, then that voltage is going to go down substantially until you get to the end of your row and then back up and make another. So what we've incorporated into the machines now is a device that actually records and counts a more accurate amount of fuel, which is called an amp hour. So if on our Cyclone machine, it has 800 amp hours of fuel in the battery pack. So it records that as it's being removed from the batteries, and it displays a fuel gauge on your display, and maybe it has 8 or 10 bars there when you first start. And then as the amp hours are removed, your battery gauge goes down. And then when it gets down to a certain level, the machine does not just die in the middle of the floor. The little red light flashes and it goes into limp mode, which allows you to get it over to where you can get it on the trailer and take it back to your shop and charge it, or you can pull it over to a receptacle and plug the charger in. The chargers that we're using now on the machine, you plug that in, it probably take you a good, for 800 amp hours, you're looking at a fairly long charge time, maybe 14, 16 hours, or maybe even longer than that to go from a completely dead battery back up. But whenever it goes into the limp mode, that's depleted about 80% of your fuel, and you'll limp over and charge that back up.
So elaborating on that point, you said 14 to 16 hours of a recharge time going all the way back up to the 800 amp hours. What if you're using the 220 charger? The same 14, 16, or can it charge faster under a 220 than it will under a 110?
It will charge faster on the 220. You're probably going to look at it probably 30% faster. So if you're taking, I'm always going to try to allow it an overnight charge, because those batteries need to have time to cool off. That gives a little bit of a time to get all 12 of those batteries cooled back down and get them ready again. But whenever you're using the batteries, they get warm, and when you're charging the batteries, they get warm. And we would like for those batteries to back down to room temperature. But charging, putting 800 amp hour, not 800, but probably 700 amp hours back into those 800 amp hour battery packs, you're going to be looking at 16, 17 hours on the 110 volt charger. But on the 220, you might be looking at, 10, 12 maybe. But whenever you hit those things hard, you have to be, mindful of those batteries are sealed and they're not able to gas off like a normal wet battery would. So whenever they are charging the first 50%, they're going to hit them real hard. And then the last 20% or 10%, it's going to take a lot longer, so they don't gas those batteries off. And so it will be a little bit longer charge time.
Okay, real life scenario. Let's say out of the 800 amp hours, I only use 4. It's the end of the day. I've only drained my batteries halfway down. Should I recharge, or am I damaging my batteries by doing that? Or should I drain them all the way down and then recharge them?
In a perfect world, I'd love to see you every charge cycle. I would like to see you go down to that, use it down to where the charger or the indicator will tell you, okay, it's time to go recharge. But we live in a different world than perfect. So at the end of the day, if you use half of your life, let's go plug it in, because we want to run all day the next day if there's something big comes up. But if you go park it on the job and run that machine for 4 hours and you're going to go to lunch, don't plug it in while you're at lunch. Opportunity charging kills batteries. So just leave the machine alone, let it sit there and rest, let it cool off, go to lunch, come back, get back on it, and finish up the day, and then plug it in at the end of the day. But opportunity charging, whenever you're going to go take a smoke or get a drink or something, that is not healthy on those batteries.
Very interesting. That's not how I understood it. So that's good to know. Last question on batteries, total life cycle. From 0 to 800, how many full life cycles can I expect out of my batteries?
The industry says about 4,000 cycles. Because of the harsh environment where we're really doing a very hard, very high discharge rate on those batteries, where if those things were in a golf cart, this particular battery life, this charge of a battery would last you 6 months, because there's just so many batteries here, such a high amp hour rate. Whenever we're running our machine, we could top a couple hundred amps of removal out of those batteries. So you may not get 4,000 cycles out of that. I've seen batteries last 2 years, and I've seen them last 5 or 6, but normally about 3 to 4 years is about what you're going to get out of those.
Okay. Anything else about the Cyclone that we should touch on? Let's talk about applications, because one of the misconceptions about batteries, it is limited in the application. Is that true? Can a battery do just as well on ceramic and hardwood as a propane?
If you were to compare the Cyclone and the Hurricane, they're going to be fairly close in removal rates. You know, they're based on the same frame style. They're based, you know, pretty much the same feet per minute speed. The size as far as length and width are pretty close to the same. So you're going to get the same torque out of the wheel motors and those kinds of things. The bigger difference is at the end of the day, whenever you've depleted your battery pack on the Cyclone, you park it. On the Hurricane, at the end of the day, if you've depleted your propane tank, you throw another propane tank on it and you keep going. That's the pretty much the only difference. They're both, like I said, they have the same travel speed, same weight. They're going to do the same work.